Good morning. Today we will discuss the exam coverage for the Term 1 exam, Ministry of Education, 2025-2026. So in this exam, what we have to focus on is really just 4 or 5 topics which are repeated over and over again. So some of those topics are about radiation, about the specific heat, conductors and insulators, about the direction of flow of heat, and a few other topics. So these topics we will keep repeating again. In the exam, you will see more questions from these specific topics. So as I explain the exam coverage, you will see that. So let's try to discuss the questions. So you see here, the first question, you see this is a question which will repeat again and again. So this is about from the lesson states of matter. So in the states of matter, there are 3 states of matter: solid, liquid, and gas. So what is the difference between a solid, liquid, and gas? There are mainly 2 kinds of differences. One is that the particles in the solid, they don't move around, they stay in the place and they shake, they vibrate. So they vibrate, they don't move around. They move little bit, okay, but they don't move around. But in the liquid and in the gas, the particles can move around from their place. Okay, so they don't sit in one place. So that's one difference. And the second difference is the space. In the solid, the space between the particle is very less. The liquid a little bit more, and the gas particles, they have a lot of space between them. So you see the solid particles, they move very slowly. The liquid particles move a little bit faster. The gas particles move very, very fast. So this is the main difference. So you should be able to identify which are the states of matter. Okay, this is one thing. Okay, next one, this is another question which will keep repeating. The concept is evaporation. Okay, so the second question is, why do wet clothes dry faster on hot days than on cold days? So you know that it happens because of evaporation. So evaporation is faster when the kinetic energy of the particles of the liquid are more. So where do they get the more kinetic energy? They get it from the surrounding air. So if you put clothes for drying on the hanger after washing the cloth, the particles of water which are sticking to the clothes, they get kinetic energy when the air particles around the clothes come and collide, when they come and hit on the water particles which are sticking to the cloth. So this makes the particles of water faster. So they get more kinetic energy, and some of them, they get enough kinetic energy to break free of the attraction of the sticking force, and they escape into the atmosphere. Okay, so this is about evaporation. Okay, let's look at the next question. This is about classifying the substances into solid, liquid, and gas. Okay, so you can see here ice, steam, rock, water, juice, air. So it's very easy. So you know that ice and rock are hard, they are solid. Steam and air are gases, water and juice are liquids. Okay, let's go to question number 4. Think of a time that you noticed a change of state. Explain what happened using the terms temperature, particle motion, and energy. Okay, so you see here, you see the energy when you heat. Suppose you take a solid. Let's take the example of ice, water, and water vapor. So you take water. So let's take ice. So when you heat the ice has a temperature always below 0 degrees Celsius. So when you start heating the ice, the temperature, the harara of the ice keep on increasing, increasing, increasing. And when it reach the temperature called the melting point, the the temperature remains constant for some time, right? So, this is the second idea. So this is about the heating curve. Okay, this is the second idea which will repeat itself. So the temperature, when you heat the ice, the temperature increases, then it reaches the melting point of ice, which is 0 degrees Celsius, and uh, it uh, it becomes constant for a while. And after all the ice particles have changed into water, then it will change, then it will increase the harara again. It will increase the harara again, and slowly again it will increase the harara. After that, when it reach the boiling point temperature, again the temperature become constant for some time. Then after that, again the temperatures start increasing. When all the water change into water vapor, then it increase the temperature. So why does this happen? Because when you are reaching the uh, melting point or the freezing point or condensation point or the boiling point, that means when there is a change of state from solid to liquid, liquid to solid, or liquid to gas, or gas to liquid, when that happens, the energy that you are giving, that all that energy does not go for increasing the kinetic energy at this change of state. At the time of change of state, all the energy goes into decreasing the into increasing the potential energy of the particles. Okay, then what happens is radiation. Okay, in the radiation, what happens? Next question is about radiation. So you know what is radiation. So this is another topic which will repeat. And many questions will be about radiation, 2 or 3 questions, 2 questions, 3 questions. Okay, so radiation, in that what happens? What is radiation? It's a way of heat transfer. Heat always transfer from hot object to the cold object. So you know here that the sun is hotter than the earth. So all that electromagnetic radiation, the light and the heat from the sun reaches the earth by radiation. And this radiation is actually electromagnetic radiation. Okay, so this electromagnetic radiation can travel through vacuum. Yani there it doesn't need any matter to travel through. There need not be any touching. The earth does not have to touch the sun. There is nothing between the sun and the earth. It's empty space, no air. But still the heat from the sun can reach the earth. So that is because of radiation. That is electromagnetic waves coming from the sun to the earth. Okay. So that is what is called radiation. Okay, so this topic will repeat again. Okay, next question again. This is about ice. This is about the direction of flow of heat. So you have here ice tray which you have taken out of the fridge, and there can be a question asking from where to where is the heat flowing. Is it from the air to the ice or from the ice to the air around the ice? Okay, so you can see here the ice is colder than the air outside. So that means the air is hotter than the ice. So that means the heat from the thermal energy the heat travel from the air to the ice, right? So you should know the direction of flow of heat. It is from hot to cold. Okay. Then another idea is, how does radiation help explain the direction of thermal energy transfer between the toast and the environment? So you have toasted bread at home, right? So the toast, when it gets toasted, the bread comes out. The bread is hot, right? The bread is very hot. And when it is very hot, it tends to the bread is very hot, and then what happens? The toast is hotter than the air around, or if your hand is near the toast, it's hotter than your hand. So the hot object is the toast, and the cold object is the air or the hand which is going to get close to the toast. Okay, so that means the heat will transfer from the toast, the hotter object, to the colder object, the air or the hand nearby the toast. Okay, so you should know the direction of flow of heat. That's the other idea which will repeat in the exam. Okay, now let's look at the other idea which will repeat in the exam, which is about specific heat, insulators, and conductors. Okay, so in this question, you will see that you have a ceramic glass and you have some hot coffee which is being poured inside. So the question is about which will cool faster, a metallic cup or a ceramic cup. Okay, ceramic cup, the one you see in the picture here, that is a ceramic cup. It's made out of clay and stuff like that. So it is a bad conductor of heat. And you see the metal is a good conductor of heat. Okay, so now the thing is, what makes good conductors and what makes insulators bad conductors? The thing is, the metal does not need a lot of thermal energy to be given to it. You don't have to give too much taka to metal to change its temperature, to change its harara. You give it very little thermal energy, it's enough to increase its temperature by 1 degree Celsius. But if you're going to heat this cup, which is not made of metal, it is made of ceramic or clay, it takes a lot of time for that heat to be to increase the temperature of the cup. Okay, so that is the thing. So why does this happen? That is because the metal have low specific heat and the ceramic or say the rubber or plastic, these things, they have very high specific heat. Okay, so you need to supply a lot of heat to plastic or rubber or things like water and all to increase its temperature. Okay, so you have to give a lot of energy to it to increase the temperature. So it does not conduct heat very well. So anything which changes the temperature faster, that is a conductor. Anything that changes temperature slowly despite giving a lot of heat, that is a insulator. Okay, so now the thing is, uh, you can see here that anything that heats up faster also cools down faster. Okay, anything which has low specific heat will heat up and also cool down faster. It can change the temperature very quickly. Okay, okay, so this is the other idea. So this is about specific heat and insulators and conductors. Okay, next idea. Again, this is about the similar idea. This is about food in a metal pan and a safe glass. Okay, so metal pan is made of metal and safe glass is glass. Okay, so this glass, so the glass is actually having higher, it's a bad conductor, so it will have higher specific heat. Metal have low specific heat, right? So glass require more energy to heat up and metal will heat up very quickly because it have low specific heat. Glass need more energy to heat up, so it has high specific heat. Metal have low specific heat, so it will heat up quickly. Okay, so you should know the difference. Okay, then next question is, how does the mass of a material in the kitchenware affect its thermal energy transfer? Okay, so you see in the kitchen, the vessels that you use, the plate and all the cooking utensils that you use, the kitchenware is made of materials. If it's a very big pot, it will take more time to heat up. If it's a small pot, small cup, it takes very little time to heat up. Okay, so the mass of the substance of the material will tell you how much energy you need to give it to change its temperature. Okay, so this is because this is about how the thermal energy transfer or the change in temperature depends on the mass of the object. Okay. Okay. Now let's look at another one. This is a different topic. This is about the water cycle. Okay. So you know that in water cycle, there are several processes. Starting from the sun evaporating the water in the sea and the river, the lake and the pond. Okay. So after evaporation, all that water becomes water vapor. It goes up into the sky and it will condense, and it will condense in the sky, and there is condensation. After condensation, all this water vapor in the air, they will stick to small particles of dust, and they form the cloud. That is a condensation. After the condensation, when the temperature in the sky reduces, when it decreases, all that temperature, all that temperature will cause all that temperature will all that will cause the okay, so all that will cause the precipitation. Okay, it will cause precipitation. Okay, so it will cause precipitation. Okay, so precipitation is one thing for that. Okay, then after precipitation, what happens? Then runoff happens. So you should know all these processes. Okay, so you should know that if you keep a plastic bag, if you keep a plastic bag, and if you keep it inside some water, and if you keep the plastic bag closed and sealed, and if you keep it near a window, you see it will the water vapor will evaporate, but it's inside the bag, so it will start condensing on the surface inside the bag, right? So that's something which will happen. And then what will happen? This will become water droplets, and that is condensation. So all that water vapor change back into water, right? Okay. Then you have another idea which is called the crystallization. Okay, so you can see here snow. So snow happens because the water which has evaporated, water which has evaporated will actually become water back again when there is condensation. When the water vapor lose the energy, it become water vapor lose energy, it become water drops, and these water drops will again change into solid small particles of crystals of ice. Okay, that is what snow is. So that's what it is. Okay, then so you should know what is crystallization. And crystallization and condensation happen when the water vapor loses thermal energy. Okay, it loses thermal energy, it becomes water, or even more thermal energy is lost, it becomes crystals. So that's crystallization. Okay, so another topic, this is about how the water in the puddles like this on the roads around disappear. So where does it disappear? It disappears by by evaporation. Where does that water go? It goes into the air, into the atmosphere around that land, right? Okay, so this is easy. So next one, which of these shows condensation? So what is condensation? Condensation is when water drops form on a cold glass, right? When the water vapor change into uh, water, that is called condensation. Okay. Next one, which of these shows evaporation? So you can see evaporation is when the water change into water vapor. So you can see here steam rising from the boiling soup. This is evaporation. Okay. Next one, let's look at this. Let's look at this. Let's look at the three-dimensional thinking. Okay, so you can see here, this is about the uh, this is about how precipitation, the water from the precipitation, it comes down uh, onto the surface of the land, and then it starts flowing, right? So why does the water on the land flow? It flows because of gravity. The gravity of the earth is pulling the water down. It will pull anything down, not just water. It will pull milk down, water down, even rocks down. So everything is going down. So if you pour some water if there is some water on the top of a hill, okay, when there is a rain, all that water tries to come down. Why? Because the Earth's gravity pulls it down. Okay. Then next idea is we have to create a graphic designer to show the role of gravity in water moving on the Earth, right? So you see, this is all because of runoff. The runoff happened because of the gravity. The water will pull it down, right? Okay. Next one, you see here, the models can be used to represent systems. How did the demonstration model energy transfer between sun and the Earth? Yeah. Okay. So this question is about how the energy from the sun reached the Earth. So you know that's because of radiation, right? And when the radiation hits the surface of the Earth, it can melt the snow and the ice. It can, right, all the sun comes to the Earth and it drives the water cycle. The water cycle is given the power, the taka, by the sun's energy. The water cycle happens only because of the sun. Okay. Now, next one is about the distribution of solar energy on the surface of the Earth. So this is another key idea which you should learn. So you see, the sunlight falls directly or perpendicular or at right angle, or you say 90-degree at the middle of the Earth, near the equator of the Earth. So it is hotter. And as you go higher up to the North Pole and the South Pole, it will be colder. So as you go away from the equator, the angle between the sun rays and the surface of the Earth will tend to become more and more acute angle. From 90-degree, it will change smaller to 50-degree, 40-degree, 30-degree. And when you reach the North Pole, it becomes acute angle, very small angle. Okay. So what you see here on these lines, these are not the angle between the Earth. This 60-degree, 30-degree is not the angle between the Earth and the sun. It's called the latitude. This is the latitude. This is something else, something different. Okay. So please don't get confused. Okay. So the latitude is about how far away it is from the equator. Okay. But the angle from the sun, which I told you, that is about the angle between the sunlight and the surface of the Earth. Okay. Fine. Okay. Next one, let's look at this one, the global winds. Okay. Why the global winds? There are three global winds. Okay. If you remember, there are three global winds near the equator. Around the equator, we have the trade winds, and above that region in the northern and the southern region, southern hemisphere, you have the prevailing westerlies. Then near the North Pole and South Pole, you have the polar easterlies, right? So now the question is, why is the global wind called trade wind called a trade wind, right? You should know that. See, it's related to UAE, right? Why? Because like in olden days, like many years before, like in the 1400s, 1200s, 1100s AD, in that time, in those years, people used to do trading, any business. Okay, how do they used to do? There were people who would go on the ship. They will go to one country, they will buy something from there, and they will go to another country and sell it. Okay. So this used to happen between China, India, and countries in the Gulf. It used to happen between countries in the Gulf and the Europe. So all the ships that used to sail, they used to use the wind, because there is always a wind from the east to west near the tropics, near the equator. So it was easy for the ships to travel from the east to the west. Okay. So so this wind was used to push the ships. So you can see in this picture, the ship has some cloth on that. So this cloth used to catch the wind, this trade wind, and it used to push the ships. So that is why it was called trade wind. And this is very important, because this wind was being used for trading, for business. So that's why it's called trade wind. Okay. Now, next one is about the similar question. So you can see here, why does the wind, the ship is actually going in a curve. is going in a curve. It's not going in a straight line. Why is it going in a straight line? Because the trade winds don't go in a straight line. They actually rotate. They curve. Why do they curve? They curve because of the Earth's rotation. The Earth rotates, right? So the wind on the surface of the Earth will curve because of that. It will not go in a straight line. It will turn. Okay, so that's so what is that effect called? It's called the Coriolis effect. Coriolis effect. So Coriolis effect causes the wind to turn. Okay, next one. Let's look at this one. Why were the northeast trade wind important for uh, European sailors to travel to the New World? Why was it important? Because it could take the ships from one continent to another continent, right? So the trade winds did that for them. Okay. Next one is about the transfer of thermal energy. So this is the same thing. The heat transfers from the air to the ice, the hot object to the cold object. So this is the repeated thing. So didn't I tell you things will repeat? It's repeating. Okay, again, another question on heat transfer. So you have a small fruit pop which is kept in the fridge. You take it out after some time, the fruit pop becomes warmer and slushy, right? So it becomes like that because it gains more thermal energy from the air around, from the environment around the ice cream or the fruit pop, right? So the heat from the air around is going into the fruit pop or the ice cream and making it slushy or liquid, right? So that is also about the direction of transfer of heat from the hot object to the cold object. Okay, next one. This is about evaporation. Okay, so you see evaporation happen at the surface of the liquid or the top part of the liquid. Okay, boiling happens throughout the liquid. All the particles in the water becomes boiling. Boiling is different from evaporation. Okay, so there are two types of vaporization. One is called evaporation, the other is called boiling. So evaporation happens only at the top, only on the surface of the liquid, and boiling when you heat a liquid in the vessel on the gas, it will heat all the particles in the liquid. But in evaporation, what happened? Only the surface particles, the particles which are faster, which have more kinetic energy, they have enough energy to break free of the attraction and go up into the air around. So they escape the attraction, the sticking force, and go into the air. So that is evaporation. So evaporation is always on the surface of the water. Okay. Okay. Next one is about the subsystems of the earth, right? Subsystems of the earth. Do you know what are the subsystems of the earth? What are the subsystems of the earth? Subsystems. One is the atmosphere, right? The atmosphere is all the air, all the gases on the earth. That is called the atmosphere. Okay. The next one is all the water in the earth. Okay, all the water in the earth. So that's hydrosphere. Then you have all the land on the earth. That is called the geosphere. Geo means earth. Okay, then biosphere. Bio means life. So all the life, plants, animals, bacteria, virus, all those things, they constitute the biosphere, right? These are the subsystems of the earth. Okay, next one. You see, this is an important question. You see, this is again repeating. You see, the trade winds. Did I tell you some questions will repeat, some ideas will repeat in the exam, right? So what is that telling you? So here you should know that they will give you a round circle showing the earth. They will give you some lines like 60 degree, 30 degree, 0 degree, 30 and 60. And they will ask you to draw the global winds. So you have to draw this picture, you have to draw this arrow, and you have to label the arrows. Which one is the trade wind? Which one is the prevailing westerly? Which is the polar easterly? And all that. So this is a question which you should remember. So you should practice making this picture from your mind and to label them. Okay, so this is an important question, short question which will come most probably as a writing question. Okay, okay, now let's look at the next one, which is about the high pressure system, low pressure system. Okay, so in the you see, whenever there is a dry condition, it's a high pressure system. Whenever there is a stormy condition, rainy condition, there is a low pressure system. Okay, so so this pressure system is built because of two things. One is because of the weather front. Okay, so there is a warm front, cold front, occluded front, right? So how does that happen? So first of all, when the warm air mass goes towards the cold air mass, that's called the warm front. When the cold air mass go to the cold warm air mass, that's called the cold front. In the occluded front, there are actually three air masses, two cold air masses, and in the middle of the two cold air masses, there is a warm air mass. So one of the cold air mass will travel forward faster than the warm air mass, and it will go through and come and collide and hit the second air mass. So that is the occluded uh, weather front. Okay. So you see here, this is the boundary between the warm air front and the cold air front. This is the warm air front and this is the cold air front. So the blue is the cold, the red is the warm. Okay, and you can see the H. H is a high pressure system and L is a low pressure system. Okay. Okay, next one. It's again the fruit pop question, which we discussed. Okay, next one is motion lines. Okay, some of the particle. So if you want to show how fast a particle is moving, you just go to the particle and make a few lines. If there are more of these curvy lines around the particle, that means the particles are moving faster. If they are moving slower, that means there are fewer motion lines. So these are called motion lines. So you have to draw motion lines. So this is also a writing question. Very easy question, right? Okay, next one. What is this? This is about the change in temperature. Okay, this is about the heating curve, which we discussed before. Okay, heating curve. Okay, again, same repeat question. This is about evaporation. Again, we discussed this. Okay, so you see the same question will keep on repeating. So you see here, what is this? This is the water cycle: evaporation, condensation, precipitation, and runoff, right? Then another question which is outside all this main topics is groundwater. So where does the groundwater come from? All the rain, the snow, and all that water will go through the permeable rocks. That means rocks which have the soil which have little bit of holes or spaces in between. The water goes through the through the soil and through the permeable rocks, and it goes down into the ground and to a place where there is a impermeable rock. Yani a place where the rock is having no more spaces to let the water to pass through it. So the water does not pass through the impermeable rock, and then the water will all collect on top of the impermeable rock. Okay, because the water cannot go any more down. Okay, now this question is about radiation. So you know about radiation. So we discussed that. Okay, so this is about cold front, stationary front, occluded front, which we discussed. Okay. Okay, there is one more front which I think I didn't discuss just before. The stationary front. Stationary front is when the cold air mass and the warm air mass, they don't move towards each other. They are not moving. They are stationary. Okay, stationary means not moving. Mafi haraka. Okay. Okay, good. Okay, so now the next question. This is about the weather map, the cold front, warm front. Okay. So, yeah, okay. So, cold front, warm front. This is again the repeat question. The kitchenware. This is a repeat question. Then the kitchenware, how it transfers thermal energy, all those things. This is again the repeat question. Same question. Okay, direction of transfer of heat, right? Same repeat question. Repeat question. Right? Okay. This is again repeat question. Repeat question. Okay. So that's it. So we have covered almost all the topics. So you must keep in mind the direction of transfer of heat, specific heat, and heating care, and in conductors, insulators, and weather fronts, cold front, warm front, high pressure system, low pressure system. These are the main topics in the lesson. Okay, so try to focus on this first and then go to the other topics which are not having that many repeat questions. Okay. Okay, so thank you, boys.